recording.
All right, so hello everybody. My name is Maxime, and as you can see, that's me right there. I will be presenting the manufacturing techniques and machines of our shop. And basically, this is just a presentation to teach you guys how to actually go from the design phase to the manufacturing phase, and like what tools you should be using for certain things, like the level of precision of tools. And so pointers here. So just before I get started, I just want to do a quick reminder that to operate any heavy machinery in our shop, you need MEC 225. So literally anything powered by electricity requires 225. So, but even though it is required, there's just a lot of things that you guys, before you do take MEC 225, that you can learn by just literally watching more experienced members do, whether that be on the lathes, the mills, the CNC and everything. So there's still a lot to learn. And even for those that won't be taking MEC 225, there's just a lot of things to do inside the shop that doesn't even require power tools. Like anytime there's an assembly or disassembly of something, you don't usually need power tools. You just need your little fingers and muscles. That's it. Some things can get heavy. But then after, there's also like design work that doesn't require MEC 225, and like testing doesn't require 225. If you're driving a car, the only thing that's required is really our trust and a driver's license. But so, all right, let's get started. So I hope you guys all know what this is. If you don't, well, this is a good place to learn. So this is a wrench, as you can see. No, it's a flathead screwdriver, but basically, as I said before, this is going to be a presentation of power tools, not really hand tools. If you guys do want to get a presentation on hand tools and all the hand tools, like the measurement tools that we use in our shop, I can do a second presentation about that, but this won't be dealing with that. It's all more like the heavy machinery. So to get started, this is basically our most basic tool. It's the Dremel. It's very versatile. Basically, you can either have it portable or plug in, but you just turn it on, and then this part right here just spins really fast, and you can, depending on like what type of thing you're cutting or just the operation you're doing using it, you just slide this around to control the speed. And yeah, that's basically it. Usually our most common way of using this tool is when you're doing, so for chassis people, it would be for notching tubes. So you print a profile, you put it on a tube, and then you kind of just cut out the profile using this tool. So as you can see right here, you just apply it and it cuts stuff. Woo. And so here actually in this picture, you can see we're actually taking off welds, which hasn't been fully welded, it's just tacked on, and probably we found like using different types of measurements, we're like, oh, maybe this tube is kind of off. So we take off the weld using the Dremel, and then we can re-tack it, then we can finally weld it. But so this is using a cutting wheel, but also there's a bunch of different things you can use. So sometimes you can go from just sanding using like this bit right here, which is basically just sandpaper that turns really fast. You can also do polishing using this tool right here. And then from polishing, you can also just clean at the same time, which is, again, very useful if you're doing in the notching process of tubes and everything, because you need to make sure it's clean and everything before you actually weld. Because I'll talk about welding later, but if the metal you're welding isn't clean, there's going to be a bunch of contamination in the weld, and so that's going to weaken the weld. You're going to have some weird, it's going to look weird, and like there's you're gonna have smoke coming off. It's not gonna be pretty. So you always want to weld on the cleanest things. So one of the things you can do is use a Dremel, and it's pretty accurate. It's as accurate as you can just like holding the thing down and just like make sure it doesn't move too much. But you can get to a certain degree of precision. It's really not too precise. It's like if you want to be like like within a thou, you won't be using a Dremel. Like you'll use all the other machines. A Dremel is really just like this basic tool, and it's very for stuff. But from there, you can go into pneumatic tools. I won't be covering pneumatic tools because, again, pneumatic tool thing, presentation, I can easily do that. Okay, apparently my internet connection is unstable, so let me know if you guys just don't see me anymore. But basically, you can go into pneumatic tools and have actual brushes. So that is really how we actually clean tubes and everything. Or you can go into like die grinder if you want. If you really have to go through a lot of material, die grinder is usually useful. Or if you just want more cutting power but have like a wheel like this, you can go into angle grinder. So personally, I love sparks. I feel when sparks happen, I'm actually doing something, which isn't always true. You can also just be destroying stuff. But I mean, that's the fun of it. So basically, an angle grinder is like next level Dremels, where it's just a bigger blade, more power, more cutting power. So if you really have to cut through like some solid steel, and again, really doesn't have to be precise. Like this is, if you're going for precision, you don't use an angle grinder because oof, that thing like it like vibrates and everything. It's really hard to control. So the thing is always trying to like run away from you and everything. So it's again, this is if you really need to get something cut, like imagine like competition is something like a tube breaks and we need to re-weld the tube into the chassis. Hopefully not, because that would be oh god. But and we need to cut the tube out or something. Boom, we use an angle grinder because that thing just cuts. But again, this has a lot of power and it's kind of dangerous. So this is kind of just a reminder to show that we are trusted with all these tools. And so as much fun as we have to be very careful. And also, you won't be using an angle grinder on your first day because we need to be able to trust you too. And we start out by trusting no one. That's the general rule. And then we go from there, which seems normal. And so this goes on to more heavy machinery too. We need to be able to trust you first before you're actually allowed to use it. So, but so now, so wow, look at this cutie right here. So our next machine is the cold saw. So I forgot to tell you this at first, but I will be asking questions. So if you guys want to answer with your mic, this is recorded though. If you don't want to hear your voice, you can just type in the chat because this time I do have chat open. I learned. So why would we want to be able to cut cold in this? Because normally a saw, even if you go at it by hand or if you just use an electric saw, basically your material will heat up, and that's the purpose of a cold saw. It cuts cold. What's the point of cutting cold? If anybody wants to answer that. Yes, no. Yeah, that's basically it. You really want to retain the shape, prevent deformation. Look at big brain right there. Yes. So basically it's the deformation, and you don't want warping inside your tool and everything. Or just change the material composition and everything, because as you add heat, especially if the tube is like heat treated or something, you would actually take off this treatment by heating it up so much. So that's the purpose of a cold saw. As you can see, it's very simple. It's literally a saw, and then through this pipe right here, or this, it's not a pipe, but this tube, sorry. basically coolant flows through that, and as you press the button right here, it goes over all the blade and everything onto your workpiece, which is attached right here through a clamp. It just makes sure that if any heat is generated, instead of going inside either the saw or your workpiece, it is goes into the coolant, and then it just doesn't warm up your piece. But nevertheless, though, if you do try, like, if I was using all my power to bring down this saw right there, it would definitely heat up because so in the end, like, sure, it does prevent a lot of heating, but you also have to make sure that you're controlling it and you're not like pressing too hard on it, so it just gently does its work. So, um, oh yeah, and so the biggest thing about this is that it kind of introduces, because you guys can't see it, but right here on the machine itself, there is a low and high speed. So does anybody know why you would want low versus high speed on something, especially when you're cutting stuff? Question mark. So no. So the reason why we have different speeds is because it's depending on the material we cut. So if you have like aluminum compared to steel is much softer and everything. It doesn't require as much power to actually cut. So if you're going with aluminum, you can easily put it on basically high gear, and then it'll spin faster, and so it can easily take away a bunch of material faster, and it just, again, it's faster, no duh. But if you're cutting steel, though, if you go on high gear, it's going to try cutting as much material as possible, but at the same time, it's going so fast that it won't really be able to cut material, and then all you're going to do in the end is literally just damage the saw blade, which is never something we want to do. So at that point, you would have to switch to low gear, so it goes slower, but each pass has more torque, and so it can, well, it can easily just dig into the material and cut. So you'll see that basically all our machines kind of have a low and high gear, specifically for that reason, for depending on the material we cut. So now, if you guys didn't like this, well, we got another type of saw. It's called a bandsaw. And so here is basically the entire machine. Here's our machine in the shop. You'll see that all our machines are on the older side, but they still work though. They get up the job done, so don't discredit them. And so basically, you see this. It's like just imagine like a rope that's just aligned with, that's usually steel, and that has teeth. That's basically what a bandsaw is. You attach it to a big wheel on top, a big wheel on the bottom, and so right here is where everything gets cut. So as you can see right here, the way you cut it is you just push the piece forward, and you push it forward, this thing just cuts as a saw, and then it gets the job done. So this also introduces the different types of teeth. So again, why would you want different type of teeth on a bandsaw? What would be the benefits right there, or like why do you have to do that? Yes, so larger teeth for wood. Again, it is due to the type of material, because on a bandsaw you can really cut a lot of different materials, but depending on that material and how hard it is, you will have to adapt the size of the teeth. So again, if you're cutting wood compared to like literally any type of metal is really soft. So that means that you don't have to go with very small passes. You can go with larger passes that will take away more material at once and basically make it faster. If you're cutting steel though, and that thing is just trying to cut as much material off of it, you're literally just gonna shave off all these teeth right here, and then you're just gonna have a dull blade. And again, you're just gonna destroy the blade. So at that point, you would have to switch to basically the smallest teeth you have to make sure that it's sure, like every cut is small, but it doesn't destroy the blade basically. And so we only have two types of blade. We have basically an aluminum blade and a steel blade. So aluminum blade, we kind of use it to cut everything from like wood to, well, plastic is kind of iffy because plastic sometimes it if you go too hard, it does melt and then it damages the blade, so we don't want that. But if you're careful with it and you go slowly enough, yeah, you can go to plastic or you can do aluminum. After that, you can also cut steel, but at the same time, if you're really trying to cut something on the bandsaw, might as well just cut it on the cold saw because the cold saw is just boom, and it's much better for cutting steel and everything. But you can get pretty, like, you can get some nice designs, as you can see here, depending on your control of your workpiece and how you push it through the machine. But again, if you want to do really precision work, the bandsaw has its limitations. So now I have a question for you guys. What if you took the bandsaw and then you put it on its side? You see, like that. Well, first of all, you would destroy the machine, so don't do that. But what if instead of using your precious little muscles to push, you just wanted like, oh wait, gravity exists. So you want to use gravity. That's when the gravity saw came to be about. So literally, gravity saw is the same thing as a bandsaw, but you just flip it on its side, and then instead of pushing stuff through it, you attach it right here again through this. As this here, just like the bandsaw, it just goes down and cuts it. So this has even less versatility than bandsaw. It literally, if you shake it around, well, I don't even know how you this down, but basically it cuts, and it's just easier to do because it uses the force of gravity to slowly go down. But again, if you just let it free fall, it's just gonna hit the workpiece, and then you're just gonna bust all your. Oh God, am I lagging that bad? All right. Um, yeah, I don't know how to fix my internet, guys. I'm sorry. Is it all right? I'll keep going. Yeah, just let me know if I'm disconnecting. I'll just repeat what I said. But basically, yeah, gravity saw it just cuts stuff, and it works the same way as a bandsaw, where just a gear here and a gear here, and the blade just spins. And again, depending on the material you cut, um, should I ever take off my camera? I can just, yeah, maybe it hates me because I'm using my camera. No, all right. I'll speak slower then, so that if it does disconnect, you'll hear more stuff. Um, I mean, yeah, there's really not much more to say about the gravity saw. It's if you know how to use a bandsaw, you know how to use a gravity saw. The one thing though is that there's actually a lever and like basically a knob you can turn behind that controls how fast the descent is. So again, you don't just like and it just destroy all the blade. Um, so, but there's also the good old fashion of holding the thing as it goes down, because that's also a big brain move right there. But yeah, basically that's the gravity saw. The next machine in our beautiful shop is a drill press, and if if you don't understand what a drill press is, it's basically a drill that you press down. Whoa, that's the name, drill press. So basically, here you have a truck where you put in whatever type of drill bit you want. So depending on the size hole you want, it it just you just stick it in, and then after that you tighten this part right here, and it just clamps down onto the drill bit, and then well, first turn it on. Yeah, wow. Contract lever that as you spin it, part right drops down, and then the more you cut, and then it just goes through. So honestly, our drill presses, we got a couple different drill presses, but this drill press right here, as you can see in our shop, actually has clamps right here, which clamps down on your workpiece, and then just allows you to make sure it doesn't just like start spinning and like, I don't know, just whenever something's spinning that's not supposed to be spinning happens in any of these machines, it's very scary. So these clamps just prevent that, because sometimes like if you're just holding it, it's just like, whoa. So yeah, that's not usually ideal. But just drill, you just press down. There's really not much more to say about that. And but again, so the chuck right here, you're gonna see this. All the next machines literally use chucks to hold down either drill bits, either the workpiece, and they have different types of chucks and everything. But the world lives off of chucks, basically. That's quotes right there. Yep, that's a big perfect quote for me right there. Um, all right, so now we're gonna get into our bit heavier machinery. Here is a mill. So a mill. So okay, this looks very threatening. It's really not. This usually you don't need to know every single thing on the machine to actually use it, but you should, because that means you will be using it better. But basically up here you got your motor, and here you got, whoa, high and low speeds. Whoa, look at that, it came back. Then here you don't really see in this picture, but this is where you would actually put your chuck in. And so usually mills use this type of chuck, where then you put in these collets, and all these collets have a specific diameter which clamps down on a certain diameter drill bit. And then as you push this in, all this space right here kind of just gets shut down. I mean, gets shut down. Just basically clamps the drill bit, and then that's what holds everything together. So the cool thing about the mill is that as basically the drill bit is spinning right here, you attach your workpiece on this table, again, clamping it down. And then using all these knobs here, you basically you move the x-axis, the y-axis, and then the z-axis. So here is a better picture of it. So this is actually the machine we have in our shop. So you can see right here, this is one of the knobs. So this actually controls the x direction, so this way. Here is the y direction, so it would be in and out. And then here is the z direction, where it goes up and down. And if you're a bit next level on these, you can actually have an auto feed. So instead of manually turning it at a certain speed, because again, the smoother you turn, the best the surface finish is going to be. There's actually an auto feed system which just turns it for you at a constant speed, which is really nice. All right, well, I hope you guys can still hear me. But basically, here is our machine in the shop. This is our mill. And as you can see, this thing is spinning. He's using, in this case, the Y direction to move around this table right here, while this drill is actually stationary. And right here, you can see the clamps. This little bucket right here is actually oil, which whenever you're doing cutting, it's usually ideal to have oil next to it, so to make sure that nothing gets like stuck or anything, it kind of just flows. You got many of those, which actually allow you to my internet does need some oil. So this caliber right here actually allows us to make sure we measure the dimensions of our workpiece, because when you're using the mill, this is when you can really get to a certain level of precision. If you really need a part to be a certain dimension and everything, this is when you would start using a mill. So on these knobs, you can't really see on this picture, but there's actually increments and everything that tells you, I believe it's in the thousandths of an inch, basically how much each turn is going to be and everything. While in a perfect world, of course, that would be absolutely correct, and you would be able to follow it and not need a caliper or anything. But sadly, we don't live in a perfect world. So instead of relying on all of these little increments and measurements, it'd be much better to just use a caliper, because the caliper, I hope it's actually accurate, but I would put my trust into the caliper and not really the increments. So this is when you would really need a caliper. A file is always good to use if you have like uh, caliper, not caliber. It's yeah, don't worry about it. It's a caliper. Yeah, just like the brake calipers. Yeah. So a file is always good to use because a mill will really cut into like straight edges, and if it's straight edges and you touch it, you really might cut yourself because it is metal, and if it's really sharp, easy to cut. So a file is kind of good to just rough off those those edges, and then I hope you guys know what a calculator is. At that point, you guys, I can't teach that to you guys. That's something else. Um, all right, this is an animation that's actually going to show you guys how like these different operations happen. So, nope. All right, let's try again. There we go. You know what? Let's have this beautiful little music. So as you can see, that's just straight, just drilling, just cutting through stuff, and that's the different axes. As you can see, the table move. Make it bigger. Use the this is just that you can have, but like, oh wow, internet is still. I can't even look this video. All right, you guys get the point. All right. I'm gonna shut off my camera because it's really bad. So you'll see me later. All right. Hopefully this kind of fixes the videos issue. But that's basically that's basically mills right there. So the next machine is the CNC machine. So kind of have to think about it as a automatic mill. So it's just a next level mill. Um, I won't really describe how it works and how you code it and everything because that's more really a red thing. And he did kind of go over it yesterday in our presentation of the different subsystem. But basically, the cool thing about CNC machines is first, I mean, you just program it and it does it by itself. But you must be thinking, you're like, wait, if you're doing all these different operations that require different like diameter holes and everything, how does it change parts? Well, here you go is a beautiful video right here where it shows how this is one of the ways that a CNC machine can switch tools. Well, boom, it just switches tool by itself and it goes back to just doing its work. So, and right there, the thing that's getting sprayed on it is just coolant, again, to make sure that your workpiece doesn't get too hot and everything. So that's basically the cool thing about a CNC machine. So when people talk about CNC machines, they're always like, oh, is it a 3-axis? Is it a 4-axis? Is it a 5-axis? And then you can be like, what does that mean? Well, don't worry. This beautiful man right here will explain it all to you. And don't worry, he's kind of intense, but he's All right, guys. Ooh. Yeah, I'm back. Am I? Yeah. All right. Maybe if Red, would it be possible for you to screen share?
Yeah, sure thing. Give me a brief moment.
Damn, I'm sorry, guys. This feels bad. So how are you guys doing on this beautiful day? Thank you.
Okay, I should be able to do so in a moment. I'm just loading up the slides.
Stop.
You have two versions of the slide, I think.
Okay. I just stopped my screen share.
Okay, cool. All right, and then I will. Okay, give me a brief moment before I begin.
Ooh.
Okay, Max, I should be good to go. Okay. Wait, no, I need to share with audio. Hold on. Okay, can someone let me know if the audio does not work?
Audio does not work.
Ah, rip. How do I do the thing?
You have to unshare the screen, and then right before you do share the screen, there's going to be on the bottom left of that window, it's going to say share. You have to check the
Oh,
box.
okay, share computer
Share
sound.
audio.
Okay.
Yep.
Cool.
And today we have a short video where I'm going to explain the axis of movement in a CNC machine. The table moves in two axes of movement. You have x-axis that runs across. You have y-axis that runs back to the back of the table. And you have z-axis where the spindle drops down. When you program manually or with a CAD/CAM system, you can actually rotate and move all axes at the same exact time to create any cut or profile needed. When you hear somebody talk about a fourth axis machine, it's still the X, the Y, the Z, all moving at the same time, but they add an additional axis of movement. To explain it, let's walk over to my horizontal mill and I'll show you how the A axis, the fourth axis, actually works. So over here, we have a fourth axis machine. It's actually running right now, but I don't have to stop it to open the door. I have one cluster tower, meaning the vices don't sit on the table. They actually are stacked up, and you got 4 vices around the A axis of movement. When I say A axis of movement, it's the rotation of the cluster. The spindle on a horizontal is actually horizontal, so it's coming down in Z, moving over in X, and up and down in Y. And then when you want to do the side work, the fourth axis work, you simply rotate axis A, go to the side, and hit it from the side. That's the brilliance of a fourth axis. So this part is done. It's waiting to get reloaded. I'm gonna close this door. That's a fourth axis. Now let's go see a fifth axis machine. All right, so the fourth axis was amazing, but this is my boy right here. This is the fifth axis machine. This is the machine that is locked down and loaded with work month after month because we solve problems on this machine. We're able to hit 5 different sides of a part or more depending on the complexity all at the same time, which gets rid of unnecessary setups. So on a 5-axis machine, you still have the Z's coming down, the X is across, the Y-axis is to the back of the machine, just like on the 3-axis, but now it's all about the table. On the A-axis, the table rotated, but on the 5-axis, we call it a B-axis, which would be our fourth. So the table rotates on these joints right here. The table pops up here and pops up on the other side, and it rotates. That's B-axis. As it's pivoting up, the table rotates in a circle, and that's the C-axis. So it's X, Y, Z, B, C-axis. 5 axes of movement, making it happen. So we're gonna make parts right here in America, American built, boom.
Yep. So right there was a beautiful band explaining all the different axes. Because honestly, when I first got introduced to CNC, nobody really explained to me all the axes, and I was so confused. But yeah, basically, we don't have a fifth axis because fifth axis is really like next level. As you can see, I don't know if you guys saw the eagle they were making in there, but that is very complex shape. Our but for now, no. But our CNC machine goes up to 4 axis, which is already, honestly, it's all we need to do. So if you go on to the next slide. So here is our, I don't have the pointer anymore. But basically on the right is our CNC machine going at it. As you can see, it just kind of start off as like a block of material, and then using the different passes, different tools and everything, you can technically transform it into the picture of on the left. So you see how it has a perfect circle around it. This is the reason why we use a CNC machine, because if you're on the mill and you have to cut that that circle right there down to a very precise level, all I can say is good luck. that's probably will never happen. And so the CNC machine can do the contour of that. It can also do the holes that are all around the shaft right there. But my question to you guys now is, how do we make these internal corners right here that you can see inside the tools? What can we do that on a CNC machine? Question mark? Wow. You cannot, because if something's rotating, good luck making a corner with that. Yeah, no, it would be over. So if you actually go onto the next slide. Oh, actually, yeah. So if you go back, this is actually a hub that we would be making, but we're probably going to change it because that's, as you can see, this is a really complex part to make, but it would be possible to do on the CNC. Uh, just inside, you actually have the sides, which is the part that we can't, it has corners and everything, so it's going to be hard to do. But if you go to the next machine, though, the answer is that to make these corners, you would have to use an EDM machine. And so actually the funny thing is our EDM guy is called Ed. So there you go. So on the left, you can see that's the big, huge machine right there is the EDM machine. And so it looks very scary and everything. Yeah. It looks very scary, but basically, I don't know if you can really see it, but Red, if you can show the wire, no, it's actually on the left, on the machine, right there, that is a wire. And so the wire just heats up, you just put a huge amount of current through it, and then kind of just imagine if you're using a wire to cut cheese, that's basically what the EDM machine does with metal. So looking at this beautiful video right here, we're gonna see how it happens. Okay, I mean, honestly, well, first of all, I didn't realize there was such an intense track on this. You can stop the video, honestly. I mean, yeah. But basically, yeah, you can't really see much, but that little glimmer of light right there is basically the electricity flowing through it and just cutting these rectangular shapes inside the machine. So the EDM can get to a very, very high level of precision. It just takes a long time to actually have the thing go through its process. So next slide. So here is the lathe, which is another one of our most used machines in the shop. So again, it kind of looks scary because there's a lot of different parts, but basically in the headstock, as you can see, there's a bunch of gears. Imagine just a gearbox, and to control those gears and those gear ratios, you see all those levers on the headstock. Basically, different combination of gears give you different speeds, and this is when, again, you get between the low and high speeds depending on the material you want. So all these drive the lead screw right there, which is actually the horizontal top bar that you see underneath the lathe. Yep, right there. And so that spins. It's also a safety concern, though, because if you have, this is also the reason why we don't allow long sleeves in the shop, because if your sleeve gets caught on the lead screw, I will just say bad things will happen to you. So it is a very dangerous machine, but with the proper precautions, it's not that dangerous. So the main thing is that, as you can see, there is a chuck. So the chuck it just has basically teeth that clamps down, usually on circular parts. So it's whenever you want to do something with a tube or anything like that, and you want to do different operations to it, you would just stick it into the chuck. And if it gets too long, so you don't have like a cantilever effect, you actually attach the other end into the tailstock, which can move back and forth. The way this machine works is that the tool post is on top of a carriage that you can, as with those levers, you can move left and right and in and out of the machine. And that is how you do all your cutting operations and everything. And so the tool post is the location where you change all the different tools and everything. And so if you go to the next slide, Basically, these are all the operations you can do on a lathe. So again, a lathe, you would have to use a caliper, but basically it can do a bunch of different operations to a very high level of degree of precision. So if you see this beautiful video right there, which you can put on 2x speed, because or else we'll be here for 3 years. Again, the little jam session. Imagine not using ad block. So we don't really use Neuralink in our shop because we don't really have much use for it. But it is another operation you would be able to do on the lathe. So reaming is basically another type of cutting, but it has a very specific diameter. So it's usually when you want to have a tool of known diameter and you really want it to be very precise, you use a reamer to make sure that it goes to that exact size. And again, boring it as it says in the video, it just makes the hole bigger, basically. So the one scary thing about parting, so it's usually when you're done with the tool and you just want to snip it off. If you're going with aluminum, it's very simple. You can just easily go through it. But if you're doing like steel has the property of strain hardening. So basically, the more strain you put on steel, the more it hardens, and it can actually harden to a point that it will literally destroy our cutting tool. So that's something that more experienced people will have to do, but it's just something to keep in mind if you're actually going to be using a lathe, that if you're using steel and you're parting it, you want to be able to do it in one cut. Like you have to continuously do it. There's no like go backs. It's you do it now or you never do it again. Okay, so next slide. So this is our final press space. There we go. Here is our final machine, basically, which is also my favorite machine because, as you guys know, I love sparks. But basically, it's welding. So there's two types of welding. There's MIG welding, where, okay, the process of welding is basically you throw a lot of electricity inside a material. That material melts, and then using usually a type of filler, you introduce a new material inside. It's usually some type of metal. You introduce new material inside this pool of basically molten metal, and then as it solidifies, it just makes it just kind of fuses two things together. It's usually used to just like literally connect two pieces together. The one thing though is that when you do have molten metal and it is exposed to the oxygen in the air, it will oxidize, which is not what you want to have happen in a welding situation, because it will actually reduce the strength of the weld itself. So that is why, if you guys can see in those pictures right there, there is actually an arc of just shielding gas that will make sure that it is basically isolated from the oxygen in the air. So once it actually cools off, it can protect itself then from the oxygen in the air, and then you're happy because it doesn't just destroy your weld. So the way we do it, we use TIG welding. So instead of MIG welding, where there's the wire is actually basically the filler, it's just slowly fed into the weld. We use TIG welding, as we can see on the right, where we have to, that little stake you see is actually the filler. And so MIG welding is really good for like automation, but TIG welding allows you a very, very high level of precision onto whenever you're welding. So it allows you to get into those little tiny holes that we need in order to weld our chassis together. So the problem about welding though, it is pretty intense, because so using your foot, you control how much amps actually goes through the current. Using your left or right hand, you hold the filler while holding the torch in your other hand, and then you have to move both of them at the same time, introduce the filler accurately and everything. It takes a lot. So if you go on the next slide, basically it takes a lot of patience. Okay, if you want to learn how to weld, it's going to take many, many hours. If you already know how to weld and you're going to weld, you still have to be patient, because if you go too fast, too slow, too many amps, not enough, not putting the filler at an accurate speed, you will basically mess up your weld. So whenever welding is involved, just take your time. It also takes a lot of preparation. You have to clean the tube and everything. So yeah, welding is fun, but it takes time. And so yeah, that's basically my presentation. I'm sorry it took so long, with also all these internet things, and oh my god, my bad guys. But hopefully you guys actually learned something, and you guys could actually hear me for most of it. But yeah, is there any questions really fast? I know I've been keeping you guys here for a long time. Yeah, okay. Not gonna answer that. All right, well, if there's no questions, I will bring it back to Red.